Today we are going to discuss about triangulation. Introduction. To prevent the accumulation of errors, it is necessary to provide a number of control points all over the area which will form a framework on which entire survey is to be based. Provision of such control points can be made either by one or a combination of both the methods, number one theodolite traverse or triangulation. Triangulation is more accurate than theodolite traverse as there is less accumulation of error as compared to that of the theodolite traversing. Triangulation is process of measuring the angles of a chain or a network or triangles that are being formed by the stations marked on the surface of the earth. The principle of triangulation include: number one, if all the three angles and the length of one side of a triangle are known, then by simple trigonometry the lengths of the remaining sides of the triangles can be calculated. Again, if the coordinates of any vertex of the triangle and azimuth of any side are known, then the coordinates of the remaining vertices may be computed. The side of the first triangle whose length is predetermined is called the baseline, and the vertices of the individual triangles are known as triangulation stations. To minimize the accumulation of errors in lengths, subsidiary bases at suitable intervals are provided, and to control the error in azimuth of stations, astronomical observations are made at intermediate stations. The purpose of triangulation survey is: number one, establishment of accurate control points for plane and geodetic survey of large areas by ground methods, and number two is establishment of accurate control points for photogrammetric survey of large areas. Number three, accurate location of engineering works, that is fixing the center line, terminal points and shaft of long tunnels. Another one is fixing the center line and abutments of long bridges over large rivers, and next transferring the control points across wide sea channels or large water bodies, etc., and finding the direction of the movement of clouds. So far as the classification of triangulation is concerned, it is classified as primary triangulation or first order triangulation, secondary triangulation or the second order triangulation, tertiary triangulation or the third order triangulation. Now the first one, that is the primary triangulation. It is the highest grade of triangulation system which is employed either for the determination of the shape and size of the earth's surface or for providing precise planimetric control points on which subsidiary triangulations are connected. The stations of first order triangulation are generally selected 16 to 150 km apart, and every possible precaution is taken in making linear, angular and astronomical observations and also their computations. Secondary triangulation. It is a triangulation system which is employed to connect two primary series and thus to provide control points closer together than those of primary triangulation. If any triangulation series which is carried out as a primary does not attain the standard of accuracy of that class due to unfavorable conditions may also be classified as triangulation of second order. Third, that is the tertiary triangulation. It is the triangulation system which is employed to provide control points between stations of primary and secondary order series. In the Department of Survey of India, tertiary triangulations are known as topo triangulations form the immediate control for the topographical surveys on various scales. Next is the layout of triangulation. The arrangement of the triangles of a series is known as the layout of triangulation. A series of triangulation may consist of either of following orders. First, simple triangles in chain. Second, braced quadrilaterals, or third, centered triangles and polygons. Ideal figures for triangulation. The undermentioned factors need to be kept in mind while deciding or selecting a particular figure in any of the triangulation system. The first one is simple triangles should be preferably equilateral. Second, braced quadrilaterals should be preferably squares. Third, the centered polygons should be regular. Fourth, no angle of the figure opposite a known side should be small. Whichever end of the series is used for calculations. Fifth, the angles of simple triangles should not be less than 45 degree, and in any case of quadrilaterals, no angle should be less than 30 degrees. In case of centered polygons, no angle should be less than 40 degrees. The sides of the figure should be of comparable length. Next is about the routine of triangulation survey. The entire routine of triangulation survey may be broadly classified or divided into two stages. Number one is the field work of triangulation, and number two is the calculation of triangulation. Field work of triangulation. In order to carry out the field works of triangulation, the following steps are involved. Number one is reconnaissance. Second step is the erection of signals. Third is the measurement of the baselines, and the fourth is the measurement of the horizontal angles. Now let us discuss in detail about the first point, that is the reconnaissance. Preliminary field inspection of the entire area that is to be covered by triangulation is known as reconnaissance. During reconnaissance, the surveyor goes over whole of the area and decides the best plan of working, keeping in view the main principles of surveying, that is working from whole to part. The reconnaissance survey thus requires great experience, judgment and skill. The accuracy and economy of triangulation basically depends upon the points reconnaissance survey is done. Includes the following operations. Number one is proper examination of the terrain, that is what kind of terrain it is, whether leveled or having any undulations. Second, selection of suitable positions for the baseline. Baseline is the most important line of the triangulation work. So, selection of the proper positions of the baseline is done. Third step is selection of suitable positions of triangulation stations. Next, determination of intervisibility of the triangulation stations, that is the station should be intervisible from each of them. Next, selection of conspicuous well defined natural points that are to be used as intersected points, the points observed from 2 or 3 stations. Next step is erection of signals. To define the exact position of triangulation station during observations from other stations, signals are used. Various types of signals are centered vertically over the station marks and observations are made to these signals. It is very necessary to ensure that the signals whenever used are truly vertical and are centered over the station marks. The accuracy of the total triangulation work entirely depend on the degree of accuracy of centering the signals. Greatest care of centering the transit over the station mark will be useless unless some degree of care of centering the signals is impressed upon. The classification of signals are luminous signals, opaque signals. As far as the luminous signals are concerned, luminous signals are further divided into 2 categories. Number one, that is the sun signals and night signals. Sun signals are those signals that reflects the rays of the sun towards the station of observations and are known as heliotropes. Apparently, such signals can easily be used in clear weather. Heliotropes consist of a circular plane mirror with a small hole at a center which reflect the rays of the sun and a sight vane with an aperture carrying a crosshair. The circular mirror can be rotated horizontally through 360 degree and vertically through few degrees. The heliotropes is centered over the station mark and the line of sight is directed towards the station of observation. Flashes given from station of observation fall at the center of the cross, and once it is done, heliotrope is not disturbed. Now, the heliotrope's attendant rotates the frame carrying the mirror so that the black shadow of the small central hole of the plane mirror falls exactly at the cross of sight vane. The reflected beam of rays will be seen at the station of observation. Due to motion of the sun, this small shadow also moves, and hence the attendant remains on constant alert to ensure that the shadow always remains at the cross. The following points may be noted. Number one is heliotropes do not give better results as compared to opaque signals. Second, heliotropes are found useful when the signal station is in plains and the station of the observation is on elevated ground. Now, next is the night signals. These signals are used where astronomical observations are made to stars. It consists of patromex with glowing light on the station mark. Next, the opaque signals. Opaque or non-luminous signals are used during day, are of various forms, and most commonly used are like number 1, pole signals. It consists of a round pole painted black and white in alternate and is supported vertically over the station mark on a tripod. Second is target signal under opaque signals. It consists of a pole carrying 2 square or rectangular targets placed at right angles to each other. The targets are generally made of cloth stretched on wooden frames. The pole signals and target signals are useful for sites less than a distance of 6 km. See, next point is about the pole and brush signal. It consists of a straight pole about 2.5 meter long with a bunch of long grass tied symmetrically around the top, making a cross. The signal is erected vertically over the station mark by helping a pile of stones up to 1.7 meters round the pole. A rough coat of whitewash is given to make it more conspicuous to be seen against the background. The pole and brush signal is very useful opaque signal and must be erected over every station of observation during reconnaissance survey. Next is the stone crane. It consists of stones built up to a height of 3 meter in a conical shape. This whitewashed opaque signal is very useful if the background is dark and the sighted station is at very far distance. Next is beacons. This consists of red and white cloth tied around the 3 straight poles. This can be easily centered over the station marks with a plumb bob. Beacons are useful when simultaneous observations are made at both stations. Now, the requirements of an ideal signal. A good signal should fulfill the following requirements. Number 1, it should be conspicuous, that is, it should be clearly visible from a distance against any background. Second, it should provide easy and accurate bisection by the telescope. Third, it should be capable of being accurately centered over the station mark. Fourth, it should exhibit very little phase error of bisection of the signal. Now, the measurement of baseline. As I told, the accuracy of any order of triangulation is primarily dependent upon the measurement of the baseline. Hence, in triangulation, a baseline is of prime importance. The length of a baseline depends upon the grade of triangulation. In India, for the network of first order triangulation, the bases whose length vary from 1.7 miles, that is 2.83 kilometer, to 7.8 miles or 13 kilometer. For topographical triangulation, the length of the baseline used is generally 80.46 meters. selection of a site for a baseline. Following factors must be considered for the selection of site for a baseline for any triangulation system. Number one, the ground at the site should be fairly level or uniformly sloping or gently undulating. Second, it should be free from obstructions throughout its length. Thirdly, the ground should be firm and smooth. Fourthly, the extremities of the baseline should be intervisible at the ground level. Fifth, the site should be such that well triangles can be obtained while connecting its end stations to the stations of the main triangulation. Now, next is measurement of horizontal angles. The instruments that are used for triangulation survey require great degree of refinement and accuracy. To achieve this, a small glass arc or double reading theodolites are generally used. With wide universal theodolites, horizontal and vertical circles can be read up to 1 second of arc. Recently, other types of glass arc theodolites have also been manufactured, such as Kern, Zeiss, etc. Next, we come to method of observations of horizontal angles. The horizontal angles of a triangulation system can be observed by following methods. The first is repetition method and the second is reiteration method, or also called as the direct method. Now we come to the first method, that is repetition method. This method is used when the angle is too small and especially for measuring the angle subtended by base at first station for its extension. If any angle of a triangulation series is also less than 20 degrees, the method of repetition is to be used. As far as the reiteration method is concerned, in the reiteration method, the signals of the stations are bisected successively and a value is obtained for each direction at each of the several round of observations. Now, next is the different types of triangulation stations. The triangular stations may be categorized as number 1 main stations, number 2 subsidiary stations, number 3 satellite stations, number 4 pivot stations. First, the main stations. The triangulation stations which are used to carry forward the basic network of the triangulation are known as the main stations. They are the main stations of the triangulation work. Now, second, the subsidiary stations. The triangulation stations which are used not only to provide additional rays to intersected points are known as subsidiary stations. Observations of the horizontal angles for subsidiary stations are made on 2 zeros only. Third one, that is the satellite station. The station which are selected very close to the main triangulation stations so as to avoid the intervening obstructions are known as the satellite or eccentric or false stations. The observations at satellite stations are made with the same precision as for the main stations. Next, fourth is pivot station. The stations at which no observations are made, but the angles at those stations are used for the continuity of a triangulation series are known as the pivot stations. As there is no check on the observations of the triangles involving a pivot station, it is recommended to avoid them in novel triangulation network. Triangulation computations. This includes number 1, checking the means of observed angles. Second, checking the triangulation errors. Third, checking the total round at each station. Next, computation of the length of the baseline. Next, computation of the side of the main triangle. And sixth, computation of the latitudes and the departures of each side of the triangulation net. Now, the means of observed angles. The means of the readings of two verniers for each measures and the means of the angles obtained from various rounds are checked before entering the angles in the abstract at each station. Now, checking the triangulation errors. The sum of three angles of each triangle must be equal to 180 degrees. We know that the summation of triangles is to be 180 degree, and that also indirectly checks the accuracy of work. So, checking the triangular error is very important. If there is any difference, it is to be distributed to the three angles in the ratio of their magnitudes. So, this check is to be done, and also difference, if any, is to be distributed according to the ratio of magnitudes. Next, checking the total round at a station. The sum of the individual angles which are obtained from various rounds must be equal to 360 degree. If any kind of discrepancy at any station is obtained and it is found that its value of discrepancy is large, then again the fresh round of angles must be obtained at particular station. Fourth point is about the calculation of the length of the baseline. As we know that baseline is the most important line, and whole of the triangulation accuracy is based on this. So, the calculation of the length of the baseline is very, very important. The absolute length of the baseline is obtained by applying the different corrections. Now, fifth one is about the calculation of the sides of a plane triangle. As one side and three angles of each triangle are known, right? The length of the remaining two sides of the triangle can very well be obtained by applying the sine formula. So, for example, A, B, C are the three angles, and small a, small b, c are the sides. Then the sine A upon small a equal to sine B upon small b will be equal to sine C upon small c. The electronic distance measurement, which in short is also called as EDM. This is a surveying tool that uses electromagnetic waves to measure the distance precisely. The EDM instruments are often used with theodolites or total station to increase the surveying efficiency and accuracy, because the accuracy with which the EDM measurements are done are very high, so they are very much preferred. The EDM instruments can measure a distance up to 100 kilometers and are highly reliable. So, both, that is the range and accuracy, distance calculations, observations through EDM is very high. So, it is very much preferred. The details of EDM we will be discussing at other lecture. So, dear learners, today we have discussed at length about what is triangulation, the different components of triangulation, and how important the triangulation is in any of the survey work. So, the accuracy with which the distances, the angles are to be measured, so that the plotting and the observations can be held with best possible accuracy, is bringing an end to today's lecture. Thank you.